Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 6, Lesson 2, Zero and Negative Exponents. In math, people often invent ways to extend concepts into areas that might not make sense at first. Pretty much everyone can understand what 2 to the third power means because they understand that it represents multiplying by number 2 3 times. Yet, what does 2 to the 0 power or 2 to the negative 4 mean? Does it make sense to talk about multiplying by a number a negative amount of times? Let's explore these ideas in the first exercise. Number 1, exercise. We can think of powers of 2 as representing multiplication of number of 1 repeatedly. Fill in the pattern for powers that are not negative. What does this lead you to fill in for 2 to the 0 power? So 2 to the 4th. What does that mean? Well, I'm going to have 1 times 2 times 2 times 2 times 2. And if you do the math, that turns out to be 16. 2 to the third power would be 1 times 2 times 2 times 2, which will give me 8. 2 to the second power would be 1 times 2 times 2 times 4. The pattern for 2 to the first would be 1 times 2 equals 2. So therefore, if we continue the same pattern, 2 to the 0 power would be 1. B. If positive exponents indicate multiplying the number 1 by 2 repeatedly, then negative exponents should indicate division. Let's fill the word division in. So 2 to the negative 1 is 1 divided by 2. And that is really, and I'm going to put a little red 1 in there, 2 to the first power. So if you notice, I took this 2 to the negative 1 and I put it into the basement. You're going to hear me say that often today. And when I put it down into the basement, it makes it positive. 2 to the negative second power. Well, what I did was, I said, okay, 1 divided by 2 times 2 equals 1 over 2 squared. Notice, I took that 2 to the negative second power, I moved it into the basement, so now my answer is 1/4. If I did this and continue the pattern for 2 to the negative third, I would say 1 divided by 2 times 2 times 2. Also known as 1 over 2 to the third, which equals 1/8. 2 to the negative fourth would be 1 divided by 2 to the fourth, which is equal to 1/16. 0 and negative exponents. 0 exponents. B to the 0 power is 1 as long as B does not equal 0. So 0 to the 0 power is not equal to 1. That's what that's saying. But anything else, any number or letter equal to the 0 power or set to the 0 power is equal to 1. Negative exponents. B to the n. Negative n. Because this is really over 1, you negate it and you put it right over there. Move the b to that negative n power into the basement, and now you have a positive exponent that you can work with. Let's practice. Which of the following is not equivalent to 5 raised to the negative second power? Well, if I were to rewrite this, just like we practiced in the last exercise, I'd move it to the basement and be 1 over 5 squared, which is equivalent to 1 over 25. So let's see what numbers are equivalent to that. 1 is equivalent to that. 3 is equivalent to that because it's 1 over 25. And 4 is equivalent to that as a decimal. 1/10 is the only answer that is not equivalent, so 2 is the correct answer. Exercise number 5 is still some more practice of rewriting each of the following expressions in two ways, by using the exponent rule developed in number 4D and I by simplifying using techniques we have seen in the last lesson. So 2 to the 4th divided by 2 to the 4th. Well, if I subtract 4 minus 4, it's going to give me 0. So I'm going to get 2 to the 0 power, which is equal to 1. And if I want to show you the long way at that, it's 2 times 2 times 2 times 2, all divided by 2 times 2 times 2 times 2. And in red, I'm going to show you. Cancel, 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 cancel. If I cancel everything out, I'm left with 1 and over 1, which therefore gives me 1. X to the second over x to the 7th. Well, if I subtract, I'm going to get x to the 5th. I hope you're noticing that the larger exponent is at the bottom, so my answer is going to be at the bottom, 1 over x to the 5th. Another way you can think about that is that if I do x squared minus x to the 7th because I'm subtracting my exponents, I'm going to get x to the negative 5th. If I remember, I have to put that to the bottom, just like my final answer shows me here, and it's 1 over x to the 5th. For C, I'm going to get 10 minus 6, which gives me 4. Notice that the bigger exponent's at the bottom, so my final answer is going to be 1 over 5 to the 4th. So, we now will see that the subtraction rule for exponents is consistent with negative and zero exponents. For now, we just want to be comfortable that negative exponents indicate division and positive exponents indicate multiplication. This is a great sentence in closure to put into our WSQ. So consider exercise number 6. Consider the exponential function f of x equals 16 times 2 raised to the x power. Find each of the following without using your calculator. This is a great review of back into chapter 3. All we have to do is take f of 0, and 0 is in the x position, and we plug it in for x. So I'm going to get f of 0 equals 16 times 2 raised to the 0 power. Now I want to continue to simplify that and work that problem out. So what is 2 to the 0 power? 2 to the 0 power is 1. So I'm going to do 16 times 1, which gives me an answer of 16. Now we're going to put 2 in for the x. F of x equals 16 times 2 squared. What is 2 squared? 4. 16 times 4 is going to give me 64. Now we're going to place negative 2 up in that. So I'm going to do 16 times 2 raised to the negative squared power. Well, you know that we can't work with the way it's written right here, 2 to the negative squared power. Another way of writing that is 16 times 1 over 2 squared. 16 times, what is 2 squared? 4, so over 1/4. 16 times 1/4 is 4. Notice here that you are not able to work with a problem that looks like this, when it has a negative exponent. You have to transform it so that it becomes a positive exponent. The way you do that is by taking that negative 2 squared, this 2 to the raised to the negative second power, and you put it in the basement underneath the 1, and now it turns it into a fraction.